Welcome back to Brightside. Happening overnight, one of the biggest and brightest stars in the night sky vanished momentarily as an asteroid passed right in front of it.
We were talking about this during the break. This created a one-of-a-kind eclipse. The star is Betelgeuse, a red supergiant in the constellation Orion.
Betelgeuse, a huge orange star, is about to explode, giving us a rare chance to watch closely. In 2019, Betelgeuse caught our attention with unusual surface activity, making us wonder if it was heading for a supernova. The Great Dimming event confused scientists and skywatchers, leading to various ideas. Although Betelgeuse is back to normal brightness, it hints at a future explosion. Different views emerge, suggesting the star might be burning carbon, setting the stage for an incredible cosmic event in its eventual supernova. Join us as we explore the Betelgeuse explosion that is expected to take the night sky worldwide. The big space scene. NASA said that Betelgeuse, a huge orange star, will explode soon. Explosions like this often happen in space, but we've never been able to study one up close. In 2019, Betelgeuse had a big ejection from its surface. Recent activities show that it's getting ready to explode, and we have a rare chance of seeing it happen. The night sky will light up because Betelgeuse, the big red star, is preparing for a big and explosive change. It will be a huge show in the sky when Betelgeuse explodes, and everyone worldwide can see it at night. We might finally understand why Betelgeuse has been getting dimmer. Get ready to look through your telescopes because we'll learn some surprising things that will make you see the night sky differently. The sky at night, filled with many stars, has always been a timeless source of wonder for people. Each shining point of light has a story to tell, a story of cosmic greatness. Looking at the vast space around us, we can't help but be amazed. These stars aren't just small points of light. They've been gigantic cosmic beings in the sky for a long time. Inside them are the mysteries of the universe, waiting to be discovered. One stands out with its bright light among the many stars. Betelgeuse is a famous star in our night sky, part of the Orion constellation, and about 650 light-years away from Earth. That's a big distance, around 6 quadrillion, 150 trillion, and 650 billion kilometers. To give you an idea, a quadrillion has 15 zeros. Betelgeuse is known as a red supergiant, one of the biggest types of stars in the universe. It's way larger than our sun, making it an extremely large star. Astronomers and skywatchers have been intrigued by its unique features and strange behavior for a long time, leading to extensive studies that make it a star that puzzles and inspires us. Also, considering the distance, when we look at Betelgeuse, we're looking into the past because light, despite being fast at around 300 million meters per second, takes a long time to travel through the huge space. In Betelgeuse's case, the light we see today started its journey more than 6 centuries ago. This creates an interesting puzzle. The things we see in the night sky happened many centuries ago. The light from Betelgeuse began its journey toward Earth when the Renaissance era was just starting. Every time we check out Betelgeuse, we're kind of exploring a cosmic time capsule, letting us discover the story of a star from centuries ago. All the focus in the universe is on Betelgeuse. As we delve deeper into the core of this massive celestial body, we'll uncover the story of its great dimming. This puzzling phenomenon of becoming less bright can now be explained. The Great Dimming. The sudden dimming of Betelgeuse caught the attention of people worldwide who were watching the sky from observatories. This interesting cosmic event happened between October 2019 and early 2020, and it made scientists and skywatchers curious to figure out why it happened. They called it the Great Dimming, a significant change from how bright Betelgeuse normally is. Even people looking at the night sky without special tools could see the difference. This raised interesting questions about what was happening to the star and what might happen to it. The main question that became important for astronomers was whether this dimming signaled that Betelgeuse was about to explode in a supernova, something they had been expecting for a long time. Red supergiants, like Betelgeuse, are known for regularly changing how bright they are, and that's considered a normal part of their existence. But this event was significant. As news about Betelgeuse's strange dimming spread in the scientific community, different ideas and guesses emerged. Some people thought that a massive release of gas and dust from the star's surface could be causing the dimming everyone saw. This idea showed a star going through a lot, throwing off its outer layers in a big show in the sky. Other scientists considered the possibility of a cool area on Betelgeuse's surface, imagining a part where it got much colder, making the star not as bright as usual. During this big sky event, a group of scientists, led by Kenichi Nomoto from the Kavli Institute for the Physics and Mathematics of the Universe, started to explore what was happening. What they found was surprising. They thought Betelgeuse might be smaller and closer to Earth than they originally thought. They also suggested that a cloud of dust might be the reason for the dimming. It turns out the universe has more surprises for us than we thought. At the same time, another group of astronomers, led by Hideyuki Sayo at Tohoku University in Japan, had a new idea about Betelgeuse's rhythmic pulsations. Like its heartbeat, this star keeps getting bigger and smaller, and its brightness changes too. The star follows a pattern of about 420 days, swelling and getting smaller in a cycle. As the Big Sky event ended, Betelgeuse returned to being as bright as before. But this cosmic mystery made astronomers and skywatchers wonder more about what would happen to this amazing star. One question was about the temperature drop during this time. Scientists studying Betelgeuse found things like the sunspots we see on our sun, but on Betelgeuse, they call them star spots. These star spots might be connected to the temperature drop they observed. These star spots are places on the star's surface where it gets colder. They're like strange things in space that affect how much light the star gives off. Similar to the spots on the sun, these cooler spots in Betelgeuse's magnetic field can make a difference. The changes in Betelgeuse's magnetic field, influenced by these spots, might have blocked the radiation coming from the star's center, causing the temperature to drop during the dimming time. It's like a dance in the sky where what happens on the star's surface affects how bright it is overall. These discoveries aren't just about Betelgeuse. They tell us a lot about red giants, which are big stars important for making heavy elements in the universe. Stars like Betelgeuse are like factories where elements heavier than helium are created. These elements, often called metals in space language, and how they form in red giants are important for the universe's makeup. By understanding how star spots affect temperature and radiation, astronomers can learn more about the complicated things happening in red giants. So, getting dim and colder, Betelgeuse started a big conversation among astronomers with many ideas and theories. And a discovery is about to change everything we thought we knew about this big red star. But for now, let's look at what the dimming might mean. Is a star getting dim connected to a supernova? A star becoming less bright is a regular part of life and can happen for various reasons. A supernova is a significant event that occurs when a very large star reaches the end of its life. Interestingly, there are connections between dimming and the possibility of a supernova, historically and theoretically. Many stars that eventually go supernova go through a phase where they become red supergiants. During this time, they can change how bright they are, including getting dimmer for a while. This happens due to complex things in the outer parts of the star, like pulsations and changes in convection. Some astronomers have been monitoring stars that might go supernova, but predicting them takes work. Let's imagine that the big dimming was linked to a possible supernova. If that's true, did Betelgeuse just return to normal after almost exploding? Can a star return to life after being so close to a supernova? Well, unfortunately, no, it can't. Once a big star reaches a certain point in life, it can't return. It shrinks and gets hotter, creating heavier elements like carbon and oxygen. This process continues until iron is formed in the center. Iron is special because it can't produce energy through nuclear fusion. Instead, the iron core becomes heavier until it can't resist gravity. If a star dims and then gets brighter again, it's not because of a supernova. So, let's look for a more sensible explanation for what happened. There have been many ideas and guesses to explain the big dimming, but the latest discoveries give a simpler explanation. A team from France's University Côte d'Azur took detailed pictures of Betelgeuse and found that dust made of silicon monoxide was thrown out from the star, making it less bright. They also discovered that the star getting dimmer wasn't a sign of something bad. It was a natural thing linked to the star's surface getting cooler suddenly. These findings support a theory from a 2021 study suggesting that Betelgeuse had a kind of cosmic burp when the gas came out, because the star got much colder. This got astronomers and skywatchers excited, wondering if it meant a big supernova was coming. But it's important to know that none of this is happening now. All of this has already happened in the history of the sky, and we're just seeing what happened hundreds of years ago. The event we saw in 2019 occurred more than 600 years ago in the star's life. Betelgeuse is returning to its usual brightness, preparing for a supernova. Studies from Hungary's Konkoly Observatory, led by Kenichi Nomoto from the Kavli Institute for the Physics and Mathematics of the Universe, support this exciting idea. But get ready for a surprising twist. Dr. Hideyuki Sayo has a different idea. According to this bold perspective, Betelgeuse might be in the middle of a phase where it's burning carbon, stealing the cosmic spotlight. When Betelgeuse finally reaches the end of its life and goes supernova, it will be an amazing and transformative event for the night sky. Betelgeuse exploding. Betelgeuse is changing quickly because it's really big, and it's predicted to finish its life with a big explosion called a supernova, likely happening within 100,000 years. When Betelgeuse explodes, it will be as bright as half of the moon for over 3 months, but it won't harm life on Earth. It was born in a group of stars called the Orion OB1 Association, which includes the stars in Orion's belt. But now, Betelgeuse has moved away from where it was born and is speeding through space at 30 kilometers, creating a big shockwave over 4 light-years wide. The explosion of a red supergiant like Betelgeuse is a tumultuous process, resulting in a supernova, one of the most energetic events in the universe. Here's what we can expect. The supernova will release an intense burst of neutrinos, nearly undetectable subatomic particles, reaching Earth before visible light. Soon after, the expanding shockwave from the supernova will cast its radiant glow across the night sky like a second, temporary sun. As the days turn into weeks, the supernova will undergo remarkable transformations. It will change color and brightness, creating a celestial light show that captures the imagination. This evolving spectacle will give stargazers a unique opportunity to witness the celestial fireworks up close. The aftermath of the Betelgeuse supernova will be a celestial masterpiece that will continue to shine brightly, for we stand on the precipice of the Betelgeuse supernova explosion, and we find ourselves in a unique position in the annals of cosmic history. What will become of the star? Well, in one possible scenario, the core of Betelgeuse may collapse, giving birth to a neutron star, an incredibly dense and exotic object. Alternatively, Betelgeuse's core may become massive enough to form a black hole shrouded in an event horizon from which no light can escape. A neutron star is incredibly dense, packing about 1.4 s to be seen. Studying Betelgeuse and its impending supernova is not merely about witnessing a spectacular event, it's about unraveling the complex processes that govern the life and death of stars. The insights gained from this celestial phenomenon will contribute to our understanding of stellar evolution, element formation, and the dynamic nature of our universe. Betelgeuse serves as a unique laboratory in the vast cosmic theater, offering us a front-row seat to one of the most energetic events in the depths of the night as we await the grand finale of Betelgeuse's stellar journey. The star Betelgeuse. Betelgeuse is easy to spot without a telescope because of its unique orange-red color and where it is in the Orion constellation. It's part of the Winter Triangle and sits in the middle of the Winter Hexagon. In January, it shows up in the east just after the sun goes down and stays visible from around September to March. with the best mid-December view in almost every part of the world, except for really southern parts of Antarctica. In May, for places not too far north, or June, for places not too far south, you can see this big red star for a little bit on the western horizon after sunset, and a few months later, it pops up again on the eastern horizon before sunrise. But during some months, like June, July, especially in mid-June, you can't see it with just your eyes. You'd need a telescope, except for a short time around midday in the far south of Antarctica when it's kind of twilight in the polar night and the sun is below the horizon. Betelgeuse is labeled as a semi-regular variable star, suggesting some noticeable pattern in the brightness shifts. However, the size of these changes can differ. The cycles might have various durations, and there could be times when they stay constant or have irregular periods. It likes to change its brightness. Sometimes it's the sixth brightest star, even brighter than Rigel, and sometimes it's even brighter than Capella. But when it's not bright, it can fall behind stars like Deneb and Beta Crucis and become the 20th brightest star. Betelgeuse is special because it has a strong red color, and its outer layer of gas makes it look different from more ionized stars. This outer layer has been seen moving back and forth, depending on what's happening on the star. We can't see in the light with our eyes. The near-infrared part, Betelgeuse, is the brightest thing in the sky. Betelgeuse would be the brightest star at night if our eyes could see everything. Some lists have up to 9 faint friends hanging out near Betelgeuse. They're not too bright. They are fainter than the 10th brightest star you can see. Betelgeuse is thought to be a solo star, kind of like a lone ranger in space. It's also what scientists call a runaway star, cruising without any companions or being part of a star-making gang, although where it was born is still a mystery. Pictures taken with radio telescopes in 1998 tell us that Betelgeuse has a pretty complicated atmosphere, with a temperature of around 3,450 K, which is way cooler than the gas around it. Surprisingly, this not-so-hot gas is the most common part of Betelgeuse's atmosphere. Jeremy Lim, who led the team studying this, says it's a twist in how we thought these big stars' atmospheres worked. Instead of just spreading out because of hot gas at the surface, Betelgeuse has giant swirls that push gas from its surface into the atmosphere. This is the same part of Betelgeuse where another scientist, Curvella, found a bright plume in 2009, possibly with carbon and nitrogen, extending at least 6 times the star's surface in the southwest. It was mentioned that there was a sneak peek of Betelgeuse's chromosphere using a camera on the Hubble Space Telescope that sees ultraviolet light. The images showed a bright spot in the southwest part of the star. In 1996, the chromosphere's average size was about 2.2 times the size of the star you see with your eyes, about 10 times the distance from the Sun to Earth, and it wasn't hotter than 5500 Kelvin. But in 2004, when Hubble's super-precise spectrometer took a look, it hinted at warm plasma in the chromosphere at least 1 arc-second away from the star. If we imagine the star is 197 car rides away, the chromosphere could be as big as 200 car rides. These observations showed that the warm plasma in the chromosphere hangs out with the cool gas in Betelgeuse's gas bubble and the dust in the clouds around it. Scientists are trying to understand how big stars like Betelgeuse lose mass before exploding. Despite knowing about the star's size and the significant role of red supergiants, there are still mysteries about the movements of Betelgeuse's outer layer. Telescopes, like the Very Large Telescope Interferometer, have captured events like a massive burst of gas in 2009, providing valuable clues. With improved telescope technology, astronomers hope to unravel the mystery of how stars shed mass in their later stages, which could explain why these stars eventually explode. Monitoring the stars. In the 1970s, astronomers saw big improvements in taking pictures of stars. Antoine Laberry invented speckle interferometry, which helped reduce blurriness caused by the way we see stars. This made ground-based telescopes see Betelgeuse more clearly. Infrared telescopes on Mount Wilson, Mount Locke, and Mauna Kea in Hawaii improved. and scientists could look at the stuff around Betelgeuse more closely. They thought there might be big gas bubbles around the star because of how it moves. In the late 1980s and early 1990s, there were more breakthroughs in taking pictures of Betelgeuse. A new method called aperture masking interferometry, created by J.E. Baldwin and the Cavendish Astrophysics Group, used a small mask with holes to turn the telescope into a makeshift camera. This gave accurate measurements of Betelgeuse, showing bright spots on the star. These were the first pictures of a star's surface, and they supported a theory from Schwarzschild that big convection cells dominate the star's surface. In 1995, the Hubble Space Telescope took a picture of Betelgeuse in ultraviolet light, giving a clearer image than ground-based telescopes. This was the first direct image of another star's surface. Space telescopes best do ultraviolet light observations because Earth's atmosphere absorbs this light. The picture showed a bright patch in the southwestern part, indicating a region hotter than the rest of the star. Later observations suggested that this hot spot was one of Betelgeuse's poles of rotation, showing the star's axis is tilted about 20° to Earth's direction. What occurs when a star explodes? When a star, like the Sun, gets old, it throws its outer parts into space, and its hot, dense core cools over a long time. But some stars end their lives with really big explosions called supernovae. A supernova can be as bright as a galaxy with billions of normal stars. Some of these explosions destroy the star completely, while others leave behind a superdense neutron star or a black hole, a thing with gravity so strong that not even light can escape from it. There are two main types of supernovae, type Y and type 2. They're named based on what's thrown into space and how the stars get brighter and dimmer. As scientists find more supernovae, the line between these two types becomes less clear. The most famous type Y supernovae are called type Ia. A type Ia probably happens when a white dwarf star, the leftover of a medium-sized star like the Sun, explodes into pieces. Scientists believe white dwarfs cause type Ia supernovae because these explosions usually occur in places with mostly older stars. This suggests that a type Ia is the explosion of a long-lived star. Stars that live a long time can't be massive, supporting the white dwarf theory. Also, the light from type Ia supernovae shows very little or no hydrogen, the most common element in the universe. Instead, they show a lot of carbon and oxygen, which white dwarfs are made of. The biggest mass a white dwarf can have is 1.4 times that of the Sun, called the Chandrasekhar limit. Almost all white dwarfs close to this limit explode in almost the same way. The most popular idea for making a white dwarf star explode into a supernova is through something called stellar cannibalism. If a white dwarf has a nearby friend star, it might take gas from the friend's surface. If the white dwarf gets too heavy because of the collected material, it might explode and leave nothing behind. On the other hand, stars that go through type 2 supernovae probably form in a galaxy's spiral arms, where many young, bright stars are found. These stars don't live long enough to move away from their birthplace, and they have to be big because of their short lives. A regular type 2 supernova gets bright in a week or two and stays almost the same for up to 2 months. After that, it suddenly goes down and then gets dimmer over the next few months. The way the light changes over time matches the explosion of a supergiant star. A supergiant star goes through stages that make heavier elements in its core, from hydrogen to helium, carbon, oxygen, and more. But this ends violently when the core turns into iron. Iron can only take in nuclear energy, not make it. Since it can't make energy anymore, the star loses its internal pressure source and collapses. When the collapse reaches a certain point, it stops. At this stage, the stuff in the star's core is packed so tightly that a small piece of it, like a sugar cube, would weigh millions of tons. The core becomes a neutron star, heavier than the Sun, but only a few miles wide. The collapse process releases a lot of energy, tearing the star's outer parts into pieces and throwing them into space at a few percent of the speed of light. These pieces carry elements like helium, calcium, oxygen, carbon, and more into space, where they might become part of new stars and planets someday. Some examples of stars that exploded include Lupus, which many people on Earth saw, making it the brightest recorded stellar event in apparent magnitude. Ophiuchus and Kepler's star are also examples, with Kepler's star being the latest easily seen exploding star in our Milky Way galaxy. Cassiopeia and Andromeda are other examples, and Ursa Major has been one of the most luminous exploding stars in the northern sky since 1954. Lynx had the first supernovae in this galaxy. 3 more were detected later. Pisces, whose star can be seen in old pictures. These and many other explosions were predicted, just like Betelgeuse is predicted to explode sometime in the future. Let's hear your thoughts in the comments about this venture. Also, don't forget to like this video and subscribe to the channel for more. See you soon.